Hello, we're on to topic 2.3 today. We're looking at how do we compare and order real numbers now that we look at what are all of them. And what we're going to do at the end of this is we'll be able to compare and order rational and irrational numbers. We're going to see some numbers that are just crazy talk. And we're going to look at how do we compare if I got some easy to work with numbers to some of those difficult to work with numbers. Some definitions that are the same as last time. Number cannot be written in the form of a fraction, is considered an irrational number. And then a square root, when you have what two numbers multiplied by themselves to get a number, that's a square root. Example, what two numbers multiply to get 9? The answer is 3. So 9, or the square root of 9 is 3. So our key concept here, we're going to look at how do we compare rational numbers. We have to first find what other perfect squares are around it. So for example, if we're looking at what is the square root of 2, well, we can look at what numbers have perfect squares around it that are 2. So an example is 1. So we can think about the square root of 1. And then the next one is 4, the square root of 4. So 1 times 1 is 1. Square root of 1 is 1. 2 squared is 4. So we can say that the square root of 2 is between 1 and 2. That's what we're going to be practicing today. We're going to look at how do we accomplish that. All right? So let's look at a rug sale here that's going on. Courtney and Malik are buying a rug to fit a 50 square foot space. Which rug should they buy? They've got 3 options. Option number 1 is 7 by 7. So we're going to complete this operation and see how much square feet does that take up. They need to go with 50. So if we go over it, the rug won't fit. If we go under it, the rug will fit. We want to get as close to 50 and stay under, kind of like the Price is Right. 7 times 7, that is 49. So that one is 49 feet squared. You have to remember your units. If you're plugging something in on the computer or in a standardized test and you don't put that in, it won't count. Or if at the beginning is talking about square feet, that's what it's referring to as feet squared. 8 feet in diameter. Our calculation for figuring out the area of a rug, so area is how much space does this take up? It is pi times the radius squared. That turns into pi times the radius is half the distance across. So the diameter is 8 feet, so half of that is 4. So pi times 4 squared, which approximates to 3.14 times 16, which is about 54 feet squared. 16 times 6 plus 16 plus 16 is 54. So it's about 54 feet squared. That is over our limit, so we're not going to be getting that one. 6 and 8.5. I've already done the calculation here. I wrote it out. That comes out to 51 feet squared. So which of these rugs should we get? We should buy the square one, not the rectangular one, to fit the bill there. The next example, we're going to approximate an irrational number. So Darcy wants to put some ribbon shown along the diagonal of the flag that she is designing. Does she have enough ribbon? So we're going to approximate. So the diagonal is square of 74. No, the cube of square root of 74, and she's got this much. Can this fit there? We're going to figure out if this is around 8.5 feet. So we're going to approximate the square root of 74. Well, what numbers are just below and just above that are perfect squares? 64 is there, so we know 64 is less than 74, which is less than 81. I know that these two are perfect squares. Square root of 64 is a nice round whole number. That is 8. And the square root of 81 is 9. So we know that our number here is between 8 and 9. So far, so good. Does she have enough? Maybe. We'll figure that out. So to find a better approximation, we can do some squaring of decimals that are between 8 and 9. So I'm going to erase this and scroll up a bit so we can see this whole box here and work on that. So we're going to just pick some numbers in the middle. Let's start with 8.5 and square it. So 8.5 squared, and we're going to go 8.6 squared, and we're going to look at approximating our square root of 74 to see if it's close to that. I already did the calculation. 8.5 squared is 75.25, and 72. 72 and a quarter. And then the 8.6 squared is 73.96. So if we're looking at this, 8.5, because that's what she has there. If she had 8.5, it would be 72 and a quarter, but it's not quite there. It's really close when we have 8.6 squared is when we get to that. So the answer here, the length of, so square root of 74 is approximately, that's a little squiggly line up there, approximately 8.6 feet. So, does she have enough ribbon? No, she does not. She would need, just to be safe, we could say 8.7 feet of ribbon to cover the diagonal of that flag. Next example. Compare the square root of 32 and 5.51326. So we have square root of 32. What are some perfect squares that are around that? Well, if we are going to list out all of our perfect squares, this is a thing to just know and have in your head. 1 times 1 is 1. I'm just counting up. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. We just passed our number there. So we can know that the square root of 25 is less than the square root of 32, which is less than the square root of 36. So this means 5 is less than the square root of 32, which is less than 6. All right, so let's use that same method we did before. Let's jump to a decimal between these two numbers to figure that out some more. Let's start with 5.5 again, or halfway. So 5.5 squared, we'll calculate 5.6 squared, and I even did 5.7 squared. Foreshadowing, not sure why. 5.5 squared is 30 and a quarter. 5.6 squared is 31.36. And 5.7 squared is 32.49. So here's the decimal. So we're going to look at comparing. That means, is it greater than, equal to, or less than those? So are these greater than or less than or equal to each other? So 5.51 is right there, and 32 is above that. So the square root of 32 is greater than 5.51326. And if we plotted that on a number line, we would have 5.5, 5.6, 5.7. Our 5.5 would be right around there. And our square root of 32 would be right there in the middle of all that. All right, bell's about to ring. We're going to rush through this last one. Compare and order the numbers below. So pi squared is 9.8596 approximately, just by going 3.14 squared. 9.5, so this is 9.8596. 9.5 is 9.5, 9.8, 9.555, on and on and on. Square root of 94 is really close, is approximately, by doing that same process again, by 9.5 squared, 9.6 squared, 9.7 squared, 9.8 squared, we could figure out the approximation for the square root of 94. And it is about 9.7. So we're gonna order these. Let's just go least to greatest for the fun of it. So 9 1/2 is our lowest number. 9.5 repeating is the next number. Square root of 94, which was 9.7, is our next number. And then 9.8, which was just given to us. And then pi squared, which was 9.8596. All right, bye.